Welcome viewers, in this video we will see the speed control of universal motor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, speed control of universal motor. The name universal motor implies that it can be operated on both AC as well as DC supply. That's why it is called a universal motor. The main application of universal motor is the high speed applications where we need a high speed that we can use. For example, food and drink mixer and swing machines, portable drillers and vacuum cleaner. For that purpose we are using this universal motor where we are need a high speed. In that the speed control is important feature. Due to the application, the speed control is very important. So there are some methods available for a speed control purpose. Basically 3 methods are available. We'll see this one by one. The first one is the resistance method. We know that this universal motor having rotating part armature and fixed part field. Field and armature is available as usual like a DC motor. This is the rotating part armature. This is the field winding. So both are connected in series. So in resistance method, the resistor is connected. Variable resistor is connected in series with the field winding and armature. So by controlling the resistor, the current flowing through the motor will vary so that field flux produced by the field winding will vary so that speed of the motor is also varies. So by increasing or decreasing the resistance, we can increase or decrease the current, thereby increase and decrease the field winding flux, thereby the speed of the motor will increase or decrease. So as shown in the diagram, motor speed is controlled by connecting a variable resistance or in series with the motor. This method is employed for the motor used in swing machines. The amount of resistance in the circuit changed by means of foot pedal. So mainly this method is applicable in a swing machine. Swing machine, the speed is controlled using the foot pedal. By slowly pressing the foot pedal, the resistance will vary so that speed of the machine also varies. So it is one of the simplest method commonly used in the swing machines. Now we'll go to the next method. Next one is the tapping field method. The field winding, the tappings are connected. So this is a rotating part armature. The 2 poles are available. One pole is fixed. It is commonly connected. In pole 2 is permanently connected. The pole 1, there are 3 tappings are there. So by changing the tapping position, the field winding, the amount of field connected to the motor will vary, so that the field flux produced also vary. We know that flux and speed is inversely proportional. So the flux increases, speed will decrease. Flux decreases, speed will increase. So based on that, we are having 3 tappings are available. So one pole is permanently connected, another pole is connected with the tapping. See this 3 tappings given low, medium, high. So in the position 1, low means the entire field is connected. If the field is connected means field flux will increase. If the flux increase, the speed will decrease. So that is called a low. And the third one, high. See that it is connected. If the switch is connected here means the pole 1 is not connected. It is directly goes to pole 2. Pole 1 is disconnected. So the field flux will not produce. Flux will be less. So the speed will increase. So that is called a high. The high speed. Right. So while connecting low, the entire pole 1 is connected. So the field flux will be produced. More flux will be produced. If more flux is there means the speed is reduced. Speed is decreased. Speed and flux is inversely proportional. When the flux increases, speed will decreases. So that's called a low. When it is connected in high, this field is not connected. Only pole 2 is connected. So only pole 2 means the flux produced by the pole is decreases. So the speed will increases. So that it is high. So in between it is connected means around 50% is connected. So we'll get the medium speed. So here another, based on that there are 2 methods available. One is this method, connecting the pole with the tapping. And another method is we can connect the resistor wire also. wire is wounded over the fixed pole. Over that we can have a resistor wire also we can make it. So one is the pole is connected with the tappings. Another method, in pole we can wind over the resistance wire. That is another method. So in this method, a field pole is tapped at the various points and speed is controlled by varying the field strength as shown in the diagram. Field strength means if the field is connected completely, more flux produces, speed decreases. If the field is not connected, less flux will be produced, so more speed will be there. So for this purpose, we can have two methods. Either of the following two arrangement may be used. First one is the field pole is wound in various sections with a different size of wire and taps brought from the each section, right? So we can have a various section, different size and wire and taps. Different size of wire and tappings are taken, what we discussed in the diagram. Another method is nichrome resistant wire is wound over the one fixed pole and taps are brought out from the wire. So this is what we discussed in the diagram. Tappings are taken, different size of wire. In addition, we can use the nichrome resistance wire also. In that also we can control the current flowing through the field winding. So the third method is centrifugal mechanism. We know that centrifugal mechanism means if the speed is more, automatically the switch will be disconnected. Right, see the centrifugal arrangement. So this is the armature, rotating part and the field winding. So here we have the centrifugal mechanism. This is a centrifugal switch. So the external lever is there. By using the lever, we can open or close the switch. Not only centrifugal mechanism, it can be controlled in the external also. So one side the capacitor is connected, another side resistor is connected. This capacitor, during high speed, any sparking is there, that will be reduced by the capacitor. This resistor, if the switch is open, the resistor is connected to the motor, so that the current flowing through the motor is controlled, this decreases. If the switch is closed, what happens? The resistor is disconnected, bypassed. The current is directly flows to the motor, so more current will flow. So if the speed is more, the case 1, first case, if the motor is rotating at very high speed, by using external lever, we can close the switch. So that what happens, the current will flow through the resistor. So the resistor will allow only few current. Resistor will restrict the flow of current. So the current flowing through the motor is decreased, so that the speed will decrease. Case 1, motor rotating high speed, by using external lever, the switch is closed. So now the current will flow through the resistor, so the current is decreases, so that we can reduce the speed of the motor. Case 2, suppose the motor is rotating in a slow speed, then we can open this, we can close this. We can close this switch. If it is closed, what happens? Directly current will flow through the field winding. So more current will flow, so the motor speed will increases. Right. So operating from external lever, we can control the speed of the motor. Right. If the speed of the motor is high, then we are opening this centrifugal switch, so that current will flow through the resistor. Current is decreased. If the motor is rotating slowly, then we are closing this centrifugal switch. At that time, the current is directly flows, so more current will flow and the motor speed will increases. Now we'll see this detail. Universal motor, particularly those used for home food and drink mixer, have a number of speed. So the drink mixing and food mixing, we need a high speed is there and a different level of speed. Initially we need less speed, thereby we need a more speed. So in that purpose we can use. So the external lever is there. So by using that we can close or open the switch. Selection is made by the centrifugal device located inside the motor and connect as shown in the diagram. So the centrifugal switch can be closed or open according to our requirement. Now we'll see the further detail. The switch is adjustable by means of external lever. External lever is available. So we'll see the first case. If the motor speed rises above the set speed set by the lever, then the centrifugal device open two contacts. So the centrifugal switch is operated by the settings, not manually. Right? We can set the speed in the centrifugal device. So it will check the speed of the motor. If it is above the set speed, then this centrifugal device open two contact and insert the resistor R in the circuit, which cause the motor speed to decrease. Right? It's not the centrifugal switch, the external lever is there that can be used to control the centrifugal switch manually, as well as it can be set. Speed is set by the operator, so that it will check the speed. If it is more, automatically it will open the contact and insert the resistor, so that current flow will decrease, so the motor speed also decreases. Right. In the second case, when the motor runs slow, the two contact closes and short circuit the resistance. If the resistor short circuited, means the current will directly flow to the field winding, so that motor speed will rise. This process is repeated so rapidly that variation in the speed are not noticeable. If the speed variation is there, then it will make a connect. It will connect or disconnect the centrifugal switch until if it is there is no variation, it will go as usual. The resistance R is connected across the governor point as shown in the diagram, that we'll discuss in the diagram. A capacitor C is used across the contact point in order to reduce the sparking produced due to opening and closing of the point. Moreover, it prevents the pitting of contacts. Right. So in this method, centrifugal mechanism is used. With that, we have resistor and capacitor is connected. Capacitor reduce the sparking. This resistor used to control the flow of current to the field winding. If the speed is more, the switch is open. That is the mechanism set. The speed is set by the speed is set by the. We can set the speed accordingly. This centrifugal mechanism will open or close the switch. If the speed is high, it will open the centrifugal switch and connect the resistor, so that current flow will be controlled, thereby speed is controlled. If the speed is slow, it will connect the contact, so the current is flowing directly to the field winding without resistor. So the current flow will increase and the speed also increases. Right. So if any variation in the speed is this mechanism will continuously check the speed of the motor until it is rotating in a set speed. Otherwise, it will either open or close the switch to maintain the constant speed. So in this video, we discuss about the speed control of universal motor. There are three methods. One is resistor, simple method, connecting the resistor to control the flow of current, thereby control the speed. Then tapping of the field winding. Third one is centrifugal switch. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.